Today we're going to start talking about trigonometry. And the first thing we need to introduce so that we can explore these trig functions is angle measure and arc length. Most of the time when you've talked about angles, you've used something called degrees. There's 360 degrees in a circle, and that's what you've been comfortable using. Unfortunately, when it comes to actual measurements, there's a different way to measure angles called radians that actually makes more sense. So we're going to explore that a little bit with this lecture, and we're going to talk about how that affects our measuring of our arc lengths in a circle. So let's start by looking at angles in general. If we have the Cartesian plane, remember that's the real plane where we have x and y axes, and we want an angle on there. We can measure our angle. We have two rays. And remember, we start with one of them and measure the angle measure to the other. And this one we start with is called the initial ray. And this is the terminal ray. That's where we stop. So if we have an angle, we've got to have an initial ray and a terminal ray, because that tells us what our angle measure is. Now, most angles are measured from the x-axis, from the positive x-axis right here. Now, sometimes we talk about bearings, and when we're talking about bearings or courses, for example, for ships or airplanes, then we're using a compass, and we measure the bearing from north, and we go clockwise from north. So we're going to start here. Our initial ray will be here, and we'll measure clockwise around. So if we're dealing with bearings or course, we're coming off of the positive y-axis, this north, and measuring that way. But most of the time we'll be just dealing with regular physics terms and math terms, and we'll come off of the positive x-axis. So this will be our normal starting point, unless it specifically says something else. If it says it's a bearing, or if it gives you a different starting place, your initial ray is going to be on the positive x-axis. So let's get a few other definitions down here. A coterminal angle, two coterminal angles are angles in standard position, which means they come off of the positive x-axis, that have the same terminal ray. Now you may say, well, that means they're the exact same angle. That's kind of silly. Well, not necessarily. They start off here at the same place, the standard position, positive x-axis, and let's say our angle measure comes up to here. Well, we can have one that we measure around like this, and we get our angle measure there, and that starts on this initial ray and ends on this terminal ray. But you can have another one where we go all the way around and then back again, and it has the same initial ray and this same terminal ray, but it's a different angle measure. The thing about angle measures is you can have an infinite number of measurements to call the same exact angle. So we'll have to keep that in mind as we are doing these, because we can have coterminal angles that have all kinds of different numbers associated with it. Now, there's another definition that we're very rarely going to use, but you need to know it just the same. A quadrantal angle is an angle whose terminal ray lies on one of the axes. So if we have our axes, then we can have, for example, this angle here would be a quadrantal angle. So those are some different angle measure things. Now, most of the time when we deal with these angle measures, we're going to be dealing with them with relation to a circle or a right triangle. But for our angle measures right now, we're going to talk about them with a circle. So when you have a circle, you know that you have a radius of your circle, which would be from here, from the center, out to the circle itself. Because remember, the circle is just the line around the edge. So the radius tells you how far you are from that center, because what's the definition of a circle? The definition of a circle is all the points, a set of points, equidistant from one point. So they're all equidistant, they have this radius r. Now, when we've measured angles before, we've measured angles by degrees, and we've looked at it, and basically the whole circle was 360 degrees, and then the angle measure told us what portion of that circle we had. Now we're going to talk about something called radians that's going to give us a little bit different definition. The definition of a radian is when you measure off an angle such that this arc length here that it sets off is the length of the radius, then this is 1 radian. Now, a radian isn't really a unit. They really are unitless. It helps, it's kind of hard to think about it that way because it's not, because you do say they're radians, but they're not inches or meters or anything like that when you're trying to measure. There's no real degrees or real measurement with it. Now, with degrees, we would have minutes and seconds, remember? Hopefully you remember this from geometry. So 1 degree is 60 minutes, and 1 minute, equals 60 seconds. And we would write that with, say we have 45 degrees, 3 minutes, and 15 seconds. So this is the marks we would use to do that. And we'll use that a little bit, hoping that you remember that from your geometry classes. But with radians, we don't have to use all this degrees and minutes. We just use decimals. And the way we figure this out is if we have, let's see, I need a new color here. Let's say we have a radius of 1 unit, whatever that is, meters, inches, whatever, it doesn't matter. If we have a radius of 1 unit, then our circumference, remember circumference of a circle is 2 pi r, so our circumference would be 2 pi. And this gives us, gives us what's called a unit circle, which gives us a reference for all the angles. Because the circumference of a unit circle is 2 pi, then we say 2 pi radians is equal to 360 degrees. Now, this gives us a way to change between radians and degrees, because this is our measurement here, 2 pi radians, because our circumference is 2 pi units long, so the angle measures, it's 2 pi radians, which is not really a unit, but 2 pi is equal to 360 degrees, because that's what we knew a circle was. Which means that if we want to change from radians to degrees, we can say that means that pi is 180 degrees. So pi radians is equal to 180 degrees. So we use our dimensional analysis. So hopefully you've gotten to that. Some in chemistry is the biggest place where you use that. But for example, if we want 30 degrees, using that dimensional analysis, we know that 180 degrees equals pi radians. So we put this so that the degrees will cancel, and we're left with the radians there. And we see that we have pi over 6 radians, which again is not really a unit. So when you write these, you will have to leave the pi in there for certain ones, for the 30, 60, 90, all of that family, and the 45 degree angle families. And we'll talk about that some more as we get into the unit circle a little bit more. But basically, the rule of thumb is to go from degrees to radians, you multiply by pi over 180, and to go from radians to degrees, you multiply by 180 over pi, because you're going to start with radians, so you want that radian thing to cancel and be left with degrees as your unit. Make sure you understand why you multiply by these things using this dimensional analysis, and because you won't be able to remember how to do it unless you remember why we do it. So let's try a couple just to make sure we've got it. Let's say if we've got 45 degrees, we want to go from degrees to radians, which means we want the degrees to cancel. So that goes in the bottom and the radians are left. And then we just simplify it and we see that 45 degrees is pi over 4 radians. Or let's say we have pi over 3 radians and we want to change that to degrees. Well, we can use our dimensional analysis again. We want the radians to cancel, so that goes in the bottom. And then we want to be left with degrees, so that goes in the top. And when we multiply this out, we see that we get 60 degrees. So pi over 3 radians is equal to 60 degrees. Need to be able to change between degrees and radians a lot, because there's many things that you can only use radians for, but they may still give you degrees, especially right now because you're still kind of thinking in degrees from what's been common for you. So make sure you know how to change between degrees and radians and why you do it that way, and make sure you understand what a radian is, that a radian measures off an arc length that's the same as the radius. So arc lengths are the other thing that we need to look at. If we have a circle, not a very good one, but excuse my artistic ability. So if we have a circle and we measure off, we've got the radius and we've got this arc length, S. Then we need to know what the angle is there. We'll call this angle T. It's just the variable that your book uses for that. So in degrees, when we had degrees, if whatever degree measure this was, then that was what our arc length was in degrees. But that didn't really tell us how long the arc was. All it told us was what portion of the circle it was. So what we need to do is deal with radians so that we can find out exactly how long it is in relation to the radius. Now we know that if we have a circle and we measure off 1 radian, that this arc length is however long the radius is. So if this is 3 inches, then this arc length is 3 inches. So that means that if we have 2 radians, then this arc length here is 2 times whatever the radius is. So we can use that to help us figure out what the arc length is in general. So we have a circle, and let's say, wow, that's bad. Hopefully you guys are doing a better job of drawing circles in your notes than I am of doing it on this thing. Something like that. All right, so let's say we have a circle, and we come out here to some point that's the radius. It's on the x-axis, so it's r comma 0 because that's how long it is from there. It's the radius. And we want to compare it to a unit circle. Remember, we said a unit circle has a radius of 1. That's pretty terrible too, but you get the idea. So if we have a unit circle, which means it has a radius of 1, and we want to know about these arc lengths. Well, if we cut us an angle here, call this angle, we'll just call it theta. Then here's our arc length that we're looking for on this circle, and we're going to compare it to this unit one. Well, if this, we just talked about that if we have an arc length on a circle, then however many radians it is, we multiply that times the radius, and we'll get that arc length. So we have this arc, we'll call it T, and since it's a unit circle, it's however many radians. That's how long that arc is. So since this is 1 unit long, we're multiplying our, remember it's the angle times the radius, but in this case our radius is 1. So we have our arc length here. Well, you remember from geometry, hopefully, that you can use proportions for these. And you know that the arc length of the larger circle over the ratio of the arc length of the larger to the smaller is equal to the proportion of the ratio of the radius of the larger divided by the radius of the smaller. So if the arc length of the larger circle, we're calling it T, and we know that that's the angle measure that we're looking for here. And the arc length of the smaller, we called it S, equals, well, the radius of the larger one is 1, and the radius of the smaller one we don't know, it's R. And we can simplify this out so that we know that the arc length is the radius times the angle in radians. Now this is why the radians are unitless, because that way we hit, if the radius is in, say, inches, then we're multiplying inches times nothing, and we end up with inches for our arc length. And that gives us our arc length so that in an actual measurement that we can use instead of just saying it's in degrees, and that doesn't really tell us anything. So this formula here, you've got to know, and you need to understand it. I know that the explanation's kind of long and it's going to take some thought, but go back and replay it, listen to it again, think it through, read it in your book, look it up on Khan Academy. They have really good videos for those kind of things. But whatever you need to do to make sure you understand why, because you're not going to remember the formulas if you don't know why they work. So this is the arc length formula, and you need to make sure you know how to use it. For example, if we know that we have a radius of 2 inches, and we have an arc cut by an angle of pi over 6 radians, then the arc length is 2 inches times pi over 6, which is pi over 3 inches. So our arc length is pi over 3, and you can do that with a decimal if you want. It's a little over 1. But most of the time we'll just leave the pi in there, so we don't have to worry about grabbing our calculators to deal with that. So that gives you your arc length. Now you can also, of course, if you know the arc length and you know the angle, then you can find the radius. If you know the arc length and the radius, you can find the angle in radians. The biggest thing to remember is this is an angle in radians, so if you're given an angle in degrees, you first have to change it to radians before you can use this formula. We'll do some in class where we practice that and make sure we know how to do that. Let's do one last example problem, and hopefully this will kind of show us what we need to do. So find the perimeter of a 60-degree slice of large or 7-inch radius pizza. So you've got a slice of pizza, whatever your favorite happens to be, pepperoni or sausage or whatever, veggies. And you want to know what the perimeter is. Well, remember, perimeter is the length around. So we already know that the sides are 7 inches because it's a radius. And we know that this angle is 60 degrees. We need to know this length here, this arc length, so that we can figure out the whole perimeter. So in order to figure out the arc length, first we have to change our degrees to radians. We want to end up with radians. We want the degrees to cancel. So we put the pi over 180 in the bottom, or the 180 in the bottom and the pi in the top. So the degrees cancel out, and we end up with pi over 3 radians. We know that our arc length is equal to the radius times the angle in radians. So arc length is 7 inches times pi over 3 radians, which gives us 7 pi over 3 inches, which is approximately equal to 7.3 inches. So that's this arc length here. So to find the perimeter, we just have to add them up. 7 inches plus 7 inches plus 7.3 inches, and our perimeter is 21.3 inches, approximately. So we found our arc length by first changing our degrees to radians, then using this arc length formula to find the arc length, and then we found our perimeter by adding the whole thing up. Read through this section 1.1. Make sure you have gone back over this enough to understand the whys of everything, how to change degrees to radians, how to calculate arc length, how to put it all together, and make sure you've got some notes and questions written down that you can ask in class.